In this video, we're going to be looking at finding conditional probabilities. So we can use conditional relative frequencies to find conditional probabilities. So number one says, a satellite TV provider surveys customers in 3 cities. The survey asks whether they would recommend the TV provider to a friend. The results, given as joint relative frequencies, are shown in the two-way table. So first we want to find the probability that a randomly selected customer who is located in Glendale will recommend the provider. So first we need to understand what it's asking us. So we're looking at selecting a random customer that is located in Glendale. So we're given that the customer is in Glendale, and we want to find the probability that they would recommend the provider. So in other words, this is asking us to find the probability of yes, given they live in Glendale. So that means we need to remember, how do we find conditional probabilities? What was that formula? Well, we learned that the probability of B given A is equal to the probability of A and B divided by the probability of A. So you notice that the probability that's by itself on the bottom is our given event. So that means that this probability of yes given Glendale is going to equal to the probability of Glendale and yes divided by the probability of Glendale. So you'll see that these two match. Our given is in that bottom probability. So now we're going to use our table to find what these probabilities are. The probability of Glendale and yes, I see on the table that is 0.29. And then the probability of Glendale is going to be the sum of this whole column. So it's going to be this 0.29 plus 0.05. And so that is going to equal to 0.29 divided by 0.34, which is approximately 0.853. So that means that this probability is 85.3%. Okay, let's try another one. This one says, what is the probability that a randomly selected customer who will not recommend the provider is located in Long Beach? So now this time we need to figure out what our given information is, or our given event. And it says that we're selecting a customer who does not recommend. So that is our given. Our given is no, and we want to find the probability that they live in Long Beach. So this time we're finding the probability of Long Beach given they do not recommend the provider. And so using our formula, that is the probability of Long Beach and no, divided by the probability of no. So our given is always going to be on the bottom. So now looking at my table here, I see that the probability of Long Beach and no is this 0.04. And then the probability of no is going to be the sum of everything in that row. So it's going to be 0.05 plus 0.03 plus 0.04. And so when you make that calculation, you'll get that this is approximately 0.333. In other words, 33.3% chance. Okay, and then the last part asks, determine whether recommending the provider to a friend and living in Long Beach are independent events. And so for this, we need to remember the formula. Probability of B is equal to the probability of B given A. If that is true, then that means that those events are, in fact, independent events. So we need to compare the probability of Long Beach to the probability of Long Beach given yes. So first, probability of Long Beach, that's just going to be the sum of that column. So 0.32 plus 0.04, which is equal to 0.36. And I want to compare that to the probability of Long Beach given yes. And so again, using that formula, that's going to be the probability of yes in Long Beach over probability of yes. Yes in Long Beach, that is 0.32. And then the probability of yes is the sum of that row of all the yeses. So 0.29 plus 0.27 plus 0.32. And when you find that, that is approximately 0.36. And so looking at those two, I see that they are approximately the same. They're approximately 0.36 for both. And so that would mean that these are, in fact, independent.